Fibonacci and Lucas identities is what we're going to talk about today. I hope that this is going to be kind of touching on some of the things that we've talked about in the Encampment of Israel series. So anybody that hasn't looked at those can go check those out. We're going to expand on that a little bit. But I wanted to talk about this in particular. I don't know how many parts this will go, but when I started reading, I got into reading this book of Numbers. It's almost been a year ago now, November 19th of last year, so 11 days short of a year here. But as I'm doing this, I'm not a mathematician. I'm not a biblical scholar. I'm neither of these things. And so as soon as I get into that book, though, I'm thinking that okay, I need to start creating some spreadsheets and start breaking some stuff down. And of course, I get into this book and I see this, right off the bat, I'm kind of seeing to set this quarter of Israel, just as we're told in this Numbers 23 again. Who can count the dust of Jacob and number of the fourth part of Israel here. So this is kind of the thing that got me down of setting that quarter of the circle right off the bat, and then establishing this number of 605,800 as opposed to the 603,550. And of course that difference at 2250 is what I associate that number for Levi in the initial march out in Numbers 2. In this we're told, 217 is when the Levites march out after that grouping of Reuben. And then we're reminded in Numbers 2:33 here about they're not being numbered. It's commanded to Moses to not give a particular number to these grouping of Levites ages over 20. So this is what gets me down the path. This right here, 233, and some of what I'm going to talk about in this video is going to be this 233, because when I'm doing this, I'm familiar with the Fibonacci sequence, but I'm not a mathematician. I'm pretty good at math, I think, as far as, it was the one subject I enjoyed in high school because it was the one subject you didn't have to study for. Right? You didn't have to remember, history, names, dates, or any of these other things. There's not a lot of things you had to commit to memory except for maybe a formula, which sometimes they give that to you anyway, right? So generally, math to me it's just work. Right? You put in a little elbow grease, you can do the work on the problem. It's just problem solving. The answer's already on the paper. You just got to do the work. So I always kind of like math in that regard, but I'm not exactly a mathematician. I don't study these. So this Fibonacci and Lucas falls into this arena of recreational mathematics is what they call it. But you'll see from these books, I've purchased these books since, and I've studied all the connections you're going to find, and there's a lot of ties into some of the other empirical sciences you'll find in nature, a lot of natural observation that you'll find where you see these associations with Fibonacci and Lucas numbers. Now, I was aware of the Fibonacci sequence, but I didn't know anything about the Lucas numbers before I started into looking at this book of Numbers. So that's just a forward there. But at any rate, this is how you get down the path of seeing the importance of this 233, because really it ends up being it's that first census. And we're seeing that grouping of man right here that we're setting as a quarter, and we're reducing everything down by its common denominator of 50. We're seeing that this group comes down to 3029, which has two factors, that being 13 and 233, and I come to find out that 233 is the 13th Fibonacci number. And then later on I see that 233 shows up on, I find that ecliptic number for Judah. It's showing up in the Judah South portion, or the Judah North portion, right? Judah South being that ecliptic number, but then the other side of Judah being 233 times 3 as well. So I'm finding 233 show up there again, which is kind of helping point me down the path of, maybe I'm on to the right track here with these numbers. Another thing, as we talked about, was some of the gematria of Bereshit, and understanding that it's Gad's number of that extra 50 in that first census that kind of gets us pointed into that grouping of man as well, being interesting, right, or to being unique. And it's that extra 50, right? It's Gad's number of that extra 50, it reducing down to 913 Bereshit. Bereshit being the beginning of the book of John later on in the New Testament as well. And that's going to tie into another thing that helped me, was associating that. I don't know if we'll talk about that in this video or not, but in the beginning was the Word, and the Word was with God, and the Word was God. So that pattern kind of helped me out with some things on this too. We might get into that. But yeah, associating Gad, and recall with some of the gematria again of what we had seen. I did a study on, recall when we looked at the whole grouping by verse and chapter of some of these, like Gad in particular. We saw the entire verse where we're talking about Gad. It's Numbers 2:15, right? So that entire verse comes out to 2,600. With final form, it was 5,000. But if you're looking at just the counting of the number, which would be 5 and 40,000 and 650, so those 6 words together, that comes out to 2250 or 4090 in standard or final form. So 2,600, what is, you'd think that, well, what is the significance? How unique is this? Well, I went back in and I looked at every other tribe that's mentioned in their particular verse. So the entire verse in standard and final form, and then what the number count. So they're given number, like whether it was Judah, 74,600, so that the number count would be 1870 with final form 3150, and so on and so forth. Issachar would be 54,400. Zebulun 57,400. So that's an interesting number of the 7 and 50,400. So that comes out to 1618. That ends up on Zebulun. So that's kind of interesting. But you don't find too many numbers that stand out at you, except for some of these that are elevated by 10. So Judah's numbers kind of stand out. They're all multiples of 10. Issachar, his verse, but not so much the number. The rest of these numbers are all pretty odd until you get to Gad's number. Gad being the number for 7. This is where we're starting. The gematria again of the verse, 2,600, final form 5,000. And then the numbers 2250, that's the number we find for Levi. In final form, 4090. Again, Levi's number in the second census becomes 4070. We find that the number for Reuben's westward bifurcation in the second census, when Levi becomes 4070, is 4080. We also have a 4060 in here on Judah in the final form here of his verse. So that's kind of interesting that all 4 of those numbers show up. 2250, again, this is 2250 comes from finding the total of 605,800. Again, 605,800, if we were to divide this by 233, it comes out to, right, 605,800 divided by 2,600 is 233, right? So 2,600 right here is showing us, again, this is relative to this number, 605,800. So I've done some other studies in here to see if any of these other number totals, the entire total for Israel that's given, the same mechanic that you have here, 6 of hundreds, thousand, and then it would be and 300, or and 3,000s, excuse me, and 550. So that mechanic of numbers comes out to, right, we've got, these are all elevated in multiples of 10. So that's the only real numbers that stand out. Another one that stands out is going to be Ephraim's numbers. They're all multiples of 5. That's kind of interesting. 2515, again, is something that, you know, if we were to find our phi number here, so if we're going to find our phi by the square root of 5, and then we're going to add 1, and then divide by 2, and then we're going to take our number total for Levi in the second census, which was 4070, and then if we were to, this is again, remember where we multiply this by phi and we get our number for the eclipse, 6585. But if we were to divide this number by phi, we'd end up with this 2515 number, and that happens to show up in Ephraim. Remember that Ephraim, the 40,500 number that you get, it's the only one divisible by Levi's number directly of 2250. So these happen to be a multiple by 18. And then know that the only other number divisible by 18 in all of these numbers is going to be Levi's number there of 2250, which you can further divide Levi by 18 and get 125. So remember 18 tying into the number for eclipses and years and all of this. So where was I going to go with this? I forget. Okay, so anyway, just tying in 2515 and finding an interesting number for Ephraim here. The rest of these numbers, you know, they don't really stand out to you too much. Remember, again, with 233, we're going to be looking at, if we're going to look at the name, the value for the names of the tribes. So, you know, Yehuda, again, we have the Yod-He Vav-He with the Dalet on this side of the divide. That's, again, that's pretty interesting with the extra 4 to 26. But, you know, apart from that, what stands out? Well, Simeon, remember, Simeon had that Pakad, that singled out Pakad in the first census of that singular, right? There was something special being pointed out about Simeon in the first census, or in the chapter 1, when we first list the names. And you see that Simeon, we have a Shin, Mem, Ayin, a Vav, and Nun final form here. You know, that's coming out to 466, so that's a multiple of 233 again. Remember, it's Simeon's number. It's kind of special if we get into palindromics, which I won't get too deep into this, but just know that all of these numbers that we're looking at in the censuses, you know, when you mirror them and then look at the difference, you know, you're looking at all the ways that these numbers might be special. And one of the things that you see that Simeon's a little bit different because he's the only one that comes out of the given numbers minus Gad's number, which has that extra 50, and then Levi's number is one that we went and found. But Simeon's the only number that's a difference of 2 between the first and last position here. So, you know, if you take out the middle digit here, you'll see that you're always a difference of 1. So Judah, Issachar, Zebulun, Reuben, Ephraim, all these are 4 to 5, 3 to 2, 3 to 4, 6 to 7, 4 to 5, 5 to 4. So the only time that you have that difference is Simeon, 5 to 3. And Gad's is hard to figure because you have 4 in there. He's just different. And then when you find Levi, you know, once you shave off all the zeros, he reduces to 225, and that's a difference of 3. But it's just, with all the different possibilities that you could have for these numbers, it always comes out that when you look at these, mirror the numbers and look at the difference, it's Simeon. Obviously, Gad's number is singled out, but Simeon's number is the other one that kind of sticks out. It's special. Again, he's the one in that first census that he's the only one, when you're looking at these census populations of the first census here, where his grouping is larger. You know, Judah's grouping is the largest. Simeon's grouping is the largest. Ephraim's the largest. Dan's the largest. So he's the only one that has the largest grouping and is not the head of that group. So getting back to, I lost my place here. Squares, we're not talking about that today. Okay, so my thing is, we don't want to talk about this yet. I'll minimize this. Yeah, I think we're good here. So anyway, I was just looking at doing a quick study and finding out if I'm seeing anything tied into anything specific. So just to show how Gad and that gematria was unique. One thing that you do find here is the total number when you figure up 605,800. Again, this number we're going to look at. So this number is not a number mentioned. Obviously, 603,550 and 601,730 are the two totals that are mentioned. And when you're looking at the mechanics of 603,550, and then you would look and see how the mechanics would be of 605,800, it would be 600s, 1,000, and 5,000s, and 800s. And this would total, what you would get in standard is 2921. Again, that's interesting because of our 273 when we figured up the moon totals. You're going to be taking 535 moons times 27.3 moon sidereal, and that's going to come out to this number. You're going to divide this by 40 to get your adjusted year, which would be a few hours off. But then again, you're going to multiply this times 8 to get your number, to get your adjustment for Venus, and then you're going to divide this by 13 to get your Venus sidereal. So that 2921 is just a number when you're looking at the relationship of the Sun to Venus. 2921 is a number that shows up in that connection. And again, we've tied in this 2250 number not only to the Sun and Moon ratios, but also to Venus right here. So at any rate, so getting back to Fibonacci and Lucas, that's the whole purpose of this video. We're going to get into, I'll bring in this thing, because when I'm first looking at this, I find 233 and 13, so I'm thinking that there must be some unique thing about it. I did a whole study on 233, looking at the factors of this, or excuse me, the decimals, right? So I'm looking at basically taking every fraction of 233 and then finding kind of how it's tailing together. And I end up with this sort of you get this pattern that it's pretty cool, kind of this diagonal pattern. So what happens is when you look at the decimal, all the decimals, you're going to have 232 decimal places when you divide any number by 233. So that's a prime number, so you're going to get 233 decimal places. And then what happens is, it doesn't matter which numerator it is, you're going to have, it's going to be some position on this sort of, this thread. So, it's 1 over 233, then 10, and then 100. Obviously, you see how we're moving the decimal place over one position, over one position. If we go over to the last position here, we'll see how it's 0.3004291,845. So it just loops back around. So after this 0.03, 0.3, and then you're seeing how we're getting that 429 all the way through. Well, then it just loops back to the beginning. So it really doesn't matter what your numerator is. It's just going to tell you what position you're going to be in. So I ended up doing like a whole different breakdown of finding like exactly what numbers in what position, and you come up with some interesting positions of 26 and 27 are consecutive numbers, and then you're going to have this pattern. It's just going to shift over one decimal place when you go from 26 to 27. So I thought that was pretty cool that it happens at 26 and 27, and of course it happens at the other end at 207 and 206. But yeah, just so going through all these kind of studies. So I did a study like this on 233. Thought that was pretty cool. 377, I did one on this too. Obviously this is not a prime number, but you still get these same type patterns, and you get 4 different ones. So you end up with 4 different patterns for 377. These are 84 different numbers that end up in these different patterns, and then you get a whole different pattern you get 20 different inputs for 13. So all the multiples of 13. And then so your multiples of 29 here, you get 12 different ones. So 28 right here. So there's 40 total of these other 2 patterns for your multiples of 29, multiples of 13. And you get some with this, why 29 gets 2 different patterns. I don't know. It's kind of interesting, because if you sort this by pattern, no, I didn't do that right. That's fine. I won't get into that. But at any rate, yeah, what the rhyme and reason of some of these things is kind of interesting. I think if we sort it by this here, then we'll filter it by pattern. Yeah, it's kind of interesting, this pattern that you get. So these would be the multiples of 29 as your numerator of 377, and then you get this sort of pattern happening. So the 5, 6, 7, and 8, and then the 3, 4, and 9, 10 are together in a pattern. 2 and 11, 1 and 12. Yeah, just kind of interesting. So anyway, you see I'm going through, great lengths. I'm looking at all different ways kind of the mechanics of numbers is what I get down in this sort of recreational mathematics. So anyway, I'm looking at Fibonacci. So I'm like, okay, I didn't know much about this Fibonacci sequence, so I decided to play around with it. And I start looking at the intervals. So I create a Fibonacci sequence right here. And then I started looking at, okay, what is the obviously the ratio when I divide consecutive numbers, I'm going to get, it all tapers down to phi. But if I'm going to start skipping a number in between, so for this I'm skipping to the second number. So you see I'm dividing the number by not the one previous, but the next one in line. So I'm skipping 2 numbers, I'm skipping 3 and 4 and so on and so forth. And it arrives at this pattern, and I don't really understand, I didn't understand the Fibonacci pattern does this. Right? I didn't understand like a number pattern. If we were to take any number pattern and we add together 1 and 1 consecutive numbers, and we just add these together and carry this down in a sequence, and we get the Fibonacci order right here. And then we're going to take and we're going to look at the ratio from the number to its preceding number to find out, and we see that this tapers off down into this, it's closer and closer to phi, right? But what I didn't know was this works for any number sequence. It doesn't matter what your 2 numbers that you begin with are here. So if we wanted to begin with, whatever, pick a number 56, and the next number we wanted to make 783 or something. So it doesn't matter what 2 numbers you're going to start with. It's always going to, any number sequence is always going to taper off to this number for phi, this number for growth. So when you grow this sequence in this order, you see how you're getting a very high ratio, and then a lower ratio, a higher, a lower, a higher, lower, a higher, lower, so on and so forth. It's a sort of harmonic, and it's always gonna buzz down, right? It's always gonna level itself off once you get to these big numbers. Whatever number you started with here, it's just not going to mean much. So it's very quickly going to get down to this golden mean number. So, and I didn't know this. I didn't know this about any of this before I kind of started reading into this. So, of course, I'm over here doing all this kind of dummy kind of work of building tables like this. But, you know, I come through and I start seeing how these numbers are plateauing off, and I'm like, oh wow, you know, this is amazing. They're all kind of breaking off, and they're starting to become whole numbers down here. And I'm like, I wonder if anybody's ever figured this out. And of course, you know, it's been figured out since the late 1800s. So I was a little bit late to the party here. But one thing I did notice is I'm looking for 605,800. So I know that there's this number that I get that popped up in, you know, that showed up to me. And so I'm like, okay, is this a number that's going to show up in this table? So I come down to, obviously we're too far past, and this works out. So this ends up also being, we're increasing by 5. So this is going to be the sum of these two numbers. You'll see here how, I guess what I'll do is I'll make this so that you can see the sum total that I'm doing here. You'll see it down here, the sum total. So obviously this number is going to be the sum of the preceding two terms. You're getting the same thing. So the sum of your next two terms here will be this number. But I'm like, how do I grow this? Can I get close enough to this number of 605,800? So 439, I add another one, 542, and then I add another one. And I'm like, okay, that's pretty interesting. I'm pretty close. You know, you get pretty close to 605,800 here. So if you're looking at these numbers, there's a big gap here from 439. And then you're jumping up to 710, so you've gone past it by 110,000 or whatever. So, you know, you can't really hit that. And then if you're going to start adding up all the numbers, you know, previously, right now I'm adding from 271 down, and I get to the fourth one and I hit 606,965, which happens to be 1165 off, right? So 606,965. And I see it's off by 1165, which happens to be, again, a multiple of 233. That's 1165 is 233 times 5. But if I were to continue to go down, the biggest number I can get to, if I add from this number all the way down, if I go all the way back to the beginning, again, I can only add it up to that next number. So that's 710, 644. Is the number that you're going to get to. So you're basically skipping this number, and the sum total of all of this is going to be the number after, is what you find. So there's only so many numbers. The sum total of this number all the way down is going to be this number. So you can only get to so many numbers in these ranges. So the fact that you're hitting that close to 605,800, that's interesting, right? The fact that these four together, 606,965, and then now you can start doing it with these other numbers. So again, I'm 1165 is the other number I'm looking for, and it just so happens that I see that, okay, we're past it here, and I know that we're going to be past it as soon as we add, so we're going to jump down one more. 521, it's the same thing. I'm adding 521 and 322. 843 plus another 199 plus 123, and I'm at 1165 again, right here. So, yeah, so I'm seeing that basically when we're adding from the 23rd power of phi to the 26th, we're going to take that total and we're going to subtract 10, the sum total of 10 to 13, we're going to subtract those two, and we're coming up with 605,800. So, I mean, there's only so many numbers that we can get messing around with these different combinations of numbers. So I thought that was kind of interesting. Trying to think if we could get there's a bunch of other stuff I didn't do, I guess, in here that maybe I could have done. No, so yeah, at any rate, 605,800 we hit. I mean, we can't get to 603,550, we can't get to 601,730, but our adjusted number 605,800, we can do that. The harmonics, again, for those that aren't aware of how this works with the harmonics of getting closer into that whole number, of like how we get to the Lucas number. Again, this, what I find out, these are the powers of phi. So when we're multiplying phi times phi, it's going to be essentially phi plus 1, right? The third power of phi, phi to the fourth, to the fifth, to the sixth, to the seventh, so on and so forth. We're getting all the way up this chain in the powers of phi. And that's this table right here as we're going up. One of these numbers, yeah, 1364, it's interesting. That's close to 1365. So when we get in the shekel counts in chapter 3, you got to multiply 273 times 5, it comes out to 1365. So it's pretty close that it happened so close there. So that's kind of interesting. But anyway, we're ascending powers, and you see how we're just slightly off some of these whole numbers, just off of 39,603, just off of 24,476, just off of 151,27. We're just below, we're just above, we're just below, we're just above, we're just below, we're just above. So then what you do is you take your descending powers of phi, you get your 1, and you just divide it by phi to these same powers. Phi, you're dividing it by phi, phi squared, so on and so forth. And you're getting this descending order, and then what you'll see is, you know, our ascending order 1.618, descending was 0.618. Well, the difference, you're just going to subtract the tail off of this, and you're going to end up with 1. And then the next, we skip 1 and we come down 4.236. We subtract 0.236 to get 4. So we can see every other one. It's easy to see how we subtract the tails. Now this 11.09017, this is a number pattern that's going to speak to me later on. So both this 0.236 and this 0.09017, this I'm going to see, because I'm building all these, I'm experimenting and building these tables, and I'm going to notice this later on in a minute. I'll show you what that does for me. But at any rate, you're adjusting this. You're subtracting to get 1. You're adding these two together. You see our sum total is 3. So you're adding these to get 3. You're subtracting these to get 4. You're adding these to get 7, so on and so forth. And that adjustment of this harmonic, basically you're on one side of the line, the other side, and you're getting closer and closer to the line. You're never touching the line, but you're getting closer and closer and closer to the line, and that's sort of, you know, that ideal number that you're hovering around is this number sequence right here, which is the Lucas sequence. So this is how I came to understand and know the Lucas sequence, not by picking up a book and reading it, sitting here beating my head against the wall, making these tables, which, you know, it was kind of a pain, right? You're putting some effort into this but there's other fruits that you're getting. You know, I'm putting in these efforts, and I'm finding other things that are interesting, that are helping me in other ways by going through that. So it's a growth process. So what to do this? So now we got a hit on 605,800 on here, and as we're starting to learn about this Lucas and Fibonacci sequence, so we did a big study on 233 and 377. Let's see here, where were we at? So then, okay, I got some tables I got to show you. So now what I'm doing is, again, I was telling you about this book of John, and of course Bereshit, again, is kind of how you get started with understanding where to start with Gad, and Gad's number being 913 and all this. So, but anyway, Bereshit is, again, you're going to find in the book of John in the New Testament. So kind of what got me down this path was, you see I got a little box right here. Well, this is, I got, for some reason I had this idea that, and I'm watching somebody else talk about this book of John, that it's in the beginning. So if you're just taking the beginning at 0 was the Word, and the Word was with God, and the Word was God. So if you're just looking at like the subject of this as you're talking through it, you're starting beginning, and you're marrying this up to the Fibonacci sequence, right? In the beginning was the Word, and the Word was with God, and the Word was God. So the Word we can kind of associate with the ones by adding the 1 to God here, and then, right, the Word was the Word, and the Word was with God, and the Word was God. So anyway, it just got me thinking that God shows up at 2 and 5, and then I know that if I'm looking at a sequence like this, a Fibonacci sequence, I recognize that the sequence is 1, 1. People start it with a 0 right here, but the 0 is essentially telling you what the interval between the first two numbers of your sequence are. So it's 0 here, but you don't count this when you're counting out like what number you're at. So 233 is the 13th Fibonacci number. You're not going to count 0 as part of that sequence. You're going to start with your first 1 as being your start. So that's your 1, 13, 233 right here. So you'll see, like, once you get down to Lucas sequence, that starts 2, 1. Well, really, we could look at it as being 1, 3, but the interval is now 2. And we're starting 1, 2, which essentially is just one step down from our initial sequence. So your interval is 1. So your interval is 2. Your interval right here between 1 and 4 is 3. Between 1 and 5 is 4, and between 1 and 6 is 5. So this table right here is kind of, you associate in the beginning was the Word, and the Word was with God, and the Word was God. God being at 2 and 5. This starting interval being 2 and 5. Well, this sequence right here happened to produce 225 and 364. 225, of course, being that Levi number 2250. And then I noticed that further down in this sequence, right, our other number for Levi was going to be 4070, and then we know 4070 times phi is 6585, which is going to be that eclipse pattern. Well, we're off by 33 and 53, which happens to be numbers that we're finding in our sequence here as well, right? Those are consecutive numbers after 20 is going to be 33 and 53. So I'm seeing all this, and it's kind of just sort of the bells are ringing. Same thing with this 4.0917. So I'm seeing this number. So again, what I'm doing is I'm taking this and I'm comparing the numbers that I'm arriving to in these sequences, and I'm going to compare it to my base sequence. So I'm going to take this number here and I'm going to divide it by the number preceding, and I'm going to get, it would be powers of phi as I go down. Well, now I'm doing the same thing, and I'm going to say, okay, it's this number divided by the start of my sequence. I'm going to go, and that's the square root of 5. This number divided by the start of my sequence. And I'm just going to carry this all the way down. And I sort of end up with the same thing with this 4.0917 number. So I see that popping up. And so, again, like I said, in my Fibonacci sequence there, trying to think what one that was on. So I had already seen it in my powers of phi right here. So I'd already seen it before right here, that 0917. So I'm already kind of thinking there's a way that I can draw out how to get that number. And so I come up with the formula for it. So essentially you can just take, I'd seen it in other places as well. So you can actually take phi squared here. So if you're to take phi times itself, you get phi squared. And then if you multiply this times 5, you get this same pattern, 13.09017. So, once you get that, you can take and just subtract 9 from this, and you can find how you get to this number, like an actual equation. And then I came up with an actual formula of how I'm getting all of this. And then, sort of this one right here, this ends up being the ratio between the sun and the moon, but I arrived to 20 right here, kind of in the same box. So this box, anyway, 5, I see the importance of this. I see 33 and 53. This stops at 20. And for some reason, I figured, okay, indicator, I thought maybe I'd check out what's a 20 to 1. So I come over here to 20 to 1, and I run this sequence, and I arrive to right here, the ratio between the sun and the moon sidereals, this 13.36. And to check that, we can go and, what did I do? We can just, if we wanted to verify this, we could just take what we know is the pattern for the sun. So we can take our 294 times 364. That's going to be the Zadok calendar pattern. And then we're going to turn around and we're going to divide this back by 293 now, which is one less than 294, to get our actual, this is going to be right dialed into our sun number, right? Or for our year, what we're calculating for the year. So now we're going to take this and we're going to divide this number here by our ratio right here, 13.36. Again, this is going to be very close to what we get for Levi, that pattern of numbers, and it's going to come out to 27.337. Again, if we're going to look at where we find this in the actual census, divide this by 10, and then we're going to say we're going to divide this by 360 now and multiply by 605,800, and we're going to get to a number of 4,600. Where do we find 4,600? In the second census, we find it in this bifurcation of Manasseh right here, 2.733, and then also in this first census, this is the number that gets us down of understanding of the moon sidereal. Okay, this is going to be the eagle minus, the eagle minus the man divided by Levi. So you're going to get that number right there, 2733. This is kind of what got me down the whole path of seeing, of doing all of this study in the numbers. And like I said, you can go look at that Encampment of Israel series to get a better understanding of that. All right, where were we? Doggone it, I lost our place here. We got to go find, okay, yeah, we were on the clean tables. So, where was I going with this? So anyway, this kind of this idea of John right here is what gets me pointed down this. So then again, I'm looking for, okay, in what instance are we actually getting hit with, we're hitting 605,800, or even if we're trying to find 603,550, because these numbers were going to be way out of range in all of these instances. So at what point, where are we actually hitting numbers that are falling fairly close? And you see that we end up starting hitting patterns where you're kind of getting close. You're getting closer as you're coming down. As we're coming down here, I've got some of these highlighted. So I'm looking for patterns where we're hitting numbers that are interesting. This pattern was kind of interesting because you hit a number for Simeon as 365 and 137 and 45. So this is going to be Levi. This will be your bifurcation of Reuben west in the first census from the ecliptic plane. 365, 593, that's Simeon's pattern number. And then your 4070 and 6585, again, you're off by 10. And then by, 20, 26. So you're off by those amounts right there, or 16, right? 10 and 16. You're off there. So that's pretty close to a lot of numbers, and this is on a 44 to 1. Again, 44 is a number that you'll find in eclipse patterns, because 44 times 449 ends up this 19,756. And then you can, what that is that's every third eclipse. You can divide that by 3 to get your 6585.33. And then also you can just, you can subtract 1, obviously, from this, divide by 3 to get 6585 even. But remember that also on this is that that Zadok number, that 2940. So when you're multiplying that Zadok number times the square root of 5, which is here, that's 6574. So remember, that's a difference of 11 1/3 days. So this that 6574 is sort of that yearly number. If you divide this by 18, you're getting that 365 number as well, right? Because we know it's 6585.331 is going to be your eclipse pattern. We know that that's 18 years, 11 days, 8 hours. So that's 11 1/3 days. So when we multiply this out by 3 eclipse patterns, right, you're going to get that number plus 1. You're adding 1 in, which is 11 1/3 times 3, which is 34. And of course, 34, that's another, again, that's another Fibonacci number. 34 being the 9th Fibonacci number right there. 55 being the extra moons that we get in the 273. So these Fibonacci numbers, they show up a lot. 144 obviously being that, the number everybody talks about. But 233 we find in the totals. 377 being the adjustment for a 360-degree circle, or close to your 365 year. So it's kind of all in that range. But at any rate, so we're trying to find 605, 800. So you're kind of getting close once you get into 1 to 55 here. So you notice how we start getting dialed in, we start getting close to 605, 800 when we're hitting on 55. That's a Fibonacci number. So when we were back here at, 34, 134, we started getting close. We were 73.20 over. So we're getting closer and closer to it. And then it's at 89. So 89 being the 11th Fibonacci number, we're just over. We're over by 466. So we're over by, again, 233 times 2. Again, that's our number for Simeon, his gematria for his name. So we're there. We also hit on 1165 in this sequence as well, an 89 sequence. So again, you see we're getting closer and more dialed into these numbers, right? These Fibonacci numbers. So 1 to 44, 1 to 233. You start getting further and further away. 603, 550, you'd be the closest at 233 right there. So I find all that kind of interesting. As I'm crunching these numbers, and I'm looking more and closer to some of these finds. I'm sort of getting down this road. I'm trying to think what else. I think that might be all we want to do for today. That was probably a lot. I know I'm probably going too fast on some of this stuff, but yeah, maybe you probably just watch it a couple times. But there's a lot of interesting things that get drawn out when you start building out these tables like this. Again, the only number that you're going to get that's openly a Lucas number is going to be Manasseh in the first census. There's just a lot of interesting things when we start getting into the changes and the sequence finder of like how you're finding some of these numbers. But at any rate, I'll leave it there for now. We'll pick back up and probably do another part to this Fibonacci and Lucas identity series next time. Right. Thanks. We'll talk to you later.